word problems. In math, we encounter word problems all the time. On the SAT, it's primarily words that are in the problem. That's how you understand the problem. But more specific than just that, there are problems that just include long chunks of text that you really have to decipher what it means in terms of math. And those can be really difficult to understand. But I'm going to make the case that they're actually way simpler than you think. I used to struggle a lot with word problems. I used to just not fully understand how to turn it into math or what specific technique I needed to use. But after doing a bunch of them, like especially on the SAT, I realized that they all have some sort of predictable nature and they're common like things that show up on every single like word problem or on a lot of different word problems that use these specific concepts to try and trick you. But if you understand them by just practicing them a bunch of times and going through them and understanding what needs to be done to solve them, and you don't need to really think about it again because it's a problem you've encountered and you understand how to do it now. And if you just practice those kinds of problems and just encounter more of those things in word problems, it's not going to happen to you. Now, a 1600 score on the SAT, they might have started at a very low position, not fully understanding all the concepts, but just by doing practice, by encountering all the types of problems and understanding like fundamentally what were SAT word problems in math are all about, they were able to get a high score, and they only got through there from practice. Now, I'm Karthik. This is SAT Math, 3 crucial tricks for hard math problems. All right, so the first one, quadratic shortcuts. Now, there are like basic shortcuts in like quadratics, I guess in the concept of them, right? There's difference of squares, which is like a simplification method, which we use here. And there's also like shortcuts as in like a plus b squared in parentheses. Like what does that equal? Like 2ab is the middle term and you just have a squared on b squared on either end. So you just need to fully understand that and need to understand like quadratics and as a whole, how do you really go into factoring them? So if you understand factoring, if you understand roots and solutions, and you know difference of squares, like the special quadratic formula simplifications, you can understand basically any word problem. So this one is not exactly a word problem, but it uses quadratic shortcuts, which are going to be in almost any quadratic problem on the SAT that's like seems long and tedious. Now, our first step right here, pause to read it, but our first step here, we look at the problem and we see we have a, b, and a has to be greater than 0. So we only want our positive solution at the end, and we only want what the x root is. So let's eliminate y as a variable by replacing it by x. We divide by 5 in the smaller equation, and then we get 3x. So basically, we can replace y by 3x, and then we can FOIL out, right? Multiply the 2 parentheses, multiply those out, and then get a full equation, which we get negative 7x squared equals 9x squared minus 25, right? That's what that full equation equals once you simplify 3x. And you can do that extremely quickly without having to multiply it out, right? If you just know what difference of squares is, right? A squared or a minus b like squared, right? What is that? That's like a plus b times a minus b. Right? That's the difference of squares formula. And if you know that, you can just instantly turn it into 9x squared minus 25, right? And you know minus 7, and you have to add it on both sides. Then you get 16x squared minus 25. Now, how do you factor that? That is, yet again, another difference of squares, right? It turns into 4x minus 5 and 4x plus 5. And then we instantly know 5/4 is the answer. And we know since the other answer can't be negative, that the negative version of it, right, it would be plus and minus 4 if it was asking for all the roots. We only know that we need the positive one, so that's the one that we go with. But just knowing that, just focusing on the concept of figuring out what is the fastest way to solve the problem. What is the shortcut that I can use? And I don't even need to solve for y here. See how I didn't like solve for both and I only used the equation to solve in terms of one variable? Make sure you're thinking about all of those things when you're doing quadratics. Okay, quadratic terms, right? So pause to read the question. You see the equation above, like the wording of the question is so messed up. Which of the following equivalent forms of the equation displays the x-intercepts of the parabola as constants or coefficients, right? So we're looking for what is a constant or coefficient? What is this question really asking? The question is simply asking us what equation here, all of them are supposedly equivalent to the equation above, which, I haven't tested beforehand, but I'm going to assume that they're not lying to us. The x-intercepts, right, have to show up as constants or coefficients. What are those? They're literal numbers or numbers attached to the variable, right? So it's going to show up, and instantly you can factor that, right? What are two factors of negative 21 that add up to equal 4 minus 3 plus 7? And you factor that and you get your answer of 3 and negative 7, right? And the only place where that shows up and it is A. So that's literally the answer. It just asks you to factor, but the way that it phrases the question is so complicated. So you just have to understand all of the terms here. If you just understood what constants and coefficients are, you'll get the answer. You'll know it's directly A as a result of that. Okay, two unknowns. Now pause to read the question here. It can get a bit complicated. It takes a while. All right, so what exactly are we solving for here, right? How do we begin to solve this question? Now, the main idea here is that we know that these two triangles here, that the HBR triangle and the DRC triangle, we know that they're equivalent, right? Because we know that the angles are the same. So we know that those two sides, they correlate, right? And we have this bottom here, and we know that B is the midpoint. So 78 divided by 2, 39, that's what BC is equal to. It's equal to 39. So we have this square basically of EDCB. That's our square, and it's 39 by 39, right? But our point isn't dividing it by 2. So how do we get equivalency for BR and then RC? How do we make those equal? Now, we know one is X and we have the total distance, so we can figure out what RC is in terms of X, right? If we have two unknown, we have two unknown variables, right? Like what is RC and what is BR? We don't know what they are, and that's the only way we're going to figure out what those measurements are, because those are the only two that are really equivalent, right? Where we need to use this concept of the two triangles being equivalent, right? The proportion of 15 and 39 being equivalent to the proportion of BR and RC. So how do we do that? If we need to figure out a way that uses one variable. Now, in this scenario, we can easily say, oh, RC is Y and BR is X, but we get nowhere because we can't solve an equation where we only have one equation and two variables. Like, it's impossible to solve. So how do we actually get to that? You have to use one variable to represent both the values. And how do you do that, right? So we know the total distance is 39. We subtract X, and then we know that that is the value of RC, right? RC is just the value of BC subtracted by BR. So we know that the value is X and 39 minus X. So now we have a way of showing them to be equivalent. We've used the same variable to represent two unknowns, right? Every time you have two unknowns, you need to find a way to represent that with one variable. That's the key for all of these problems where you have two unknowns, where you don't know how to find the equivalency or how to basically solve it. You need to figure out one term and another term and figure out what variable is one of the terms, and then put that in the context of another term, just like we did here with 39 minus X and X. We use the same variable to represent two different terms. That every single problem on the SAT is solvable. We can agree upon that. They all have a correct answer. So we know that it must be solvable. So we know that one term must be able to be written with one variable, and same with a similar term that might be that variable or a slight differentiation of that variable. So if you have two unknowns, you basically use the variable to figure out what it is. Now, in this specific scenario, I told you the proportion already. We know that the lines have to be proportionate because the angles are. We can do a simple proportion. And this answer is a MCQ, and it was asking us what is approximately the value of X. And you'll get an answer that might be a little bit above 11, and that was the closest answer choice, 11. So the answer is around 11. On the MCQ, you would just pick 11. Thank you guys so much. I hope you learned something today.